This video lecture is on graphing exponential functions by Dr. Archie Earl. What are exponential functions? Exponential functions are functions wherein x is in the exponent. For example, f of x equals 6 to the x power. As you can see here, x is indeed in the exponent. This is the exponent here. So you can see that we have x in the exponent. So this is an example of an exponential function. Another example, f of x equals 1/5 to the 2x minus 8. As you can see here, this is the exponent. And indeed, if you look closely at that exponent, you'll see that x is in the exponent. So these are the types of functions that we're talking about graphing today. Now, the graph of the functions that we will be graphing will look like this. It's a nice smooth curve. It goes indefinitely in this direction and indefinitely in that direction. So once you graph one of these, you'll be able to look at it and you'll be able to see that the graph does indeed look like that. Now, when you're graphing these types of functions in this course, you would set up your solution table like this. As you can see there, I have x on the left and y on the right. And the numbers that you will always be using in this course for x will be those same numbers that you see in this table. We're always going to start out using these numbers. If we don't get a nice smooth curve like this, then we might have to add some more numbers. But as you can see, this is not a linear function. For a linear function, you have a straight line. And this is not a straight line, it's a curved line. But once again, we always start out with x equals -2, x equals -1, x equals 0, x equals 1, and x equals 2. Now what we have to do, class, is substitute these numbers into the function and find y. And once we do that, after we substitute these numbers into the function and find y, which is the second step, all right, then we graph the points and we draw a nice smooth curve. So let me back off on the steps here so that if you like, you can do a screenshot on these steps for graphing the exponential function. All right, let's look at an example so that we can see exactly how these steps work. Suppose we have this exponential function. F of x equals 2/3 to the x minus 1. And suppose we want to graph that function. First of all, we recall that f of x means the exact same thing as y. So we can rewrite this function as y equals 2/3 to the x minus 2. And that's what I've done here. I've rewritten the function as y equals 2/3 to the x minus 2. And now all I need to do is just substitute my numbers into that function. I'll substitute -2 into there, -1, 0, 1, and 2. And after I do that, I graph the points and draw a nice smooth curve through the points. So here you can see that I substitute -2 into the function for x. I got y equals 2/3 to the -2 minus 2. -2 minus 2 is -4. So in the next step, I get 2/3 to the -4. Now, what does negative exponent means? From your study of algebra, you learned that negative exponents mean that you have to take the reciprocal and make the exponent positive. Or you have to flip the fraction and make the exponent positive. So that's what I've done in the next step. If I flip 2/3, it will become 3/2. And if I make the -4 positive, it'll be a +4. So in the next step, we have 3/2 to the 4th. And then we break it up. We make it 3 to the 4th over 2 to the 4th. 3 to the 4th power is 81. 2 to the 4th power is 16. And then we divide to get 5.1. So in our table, we're going to have -2, 5.1 as our first point. We substitute -1 into the equation next. And as you can see, we get y equals 2/3 to the -1 minus 2. -1 minus 2 is -3. So in the next step, we get 2/3 to the -3. Negative exponent means that we flip the fraction and we make the exponent positive. Or we reciprocate the fraction, we make the exponent positive. So that's what I've done in the next step. I turn the fraction upside down, the exponent became a +3. I break that up, I make it 3 to the 3rd power over 2 to the 3rd power. 3 to the 3rd power, which means 3 times 3 times 3 is 27. 2 to the 3rd power, which means 2 times 2 times 2 is 8. That gives me 27 divided by 8. I get approximately 3.4. I substitute my other numbers in there similarly, and I get the values for them. When I substitute 0 in there, well, I've already put the rest of the values in the table. I substitute 0 using that same process. I get 2.3 for my answer. I substituted 1, I got 1.5 for my answer. I substituted 2, I got 1 for my answer. And when I graphed these points, I noticed that my graph didn't look like the curve. So I had to add on another point. So I graphed my points here. I graphed -2, 5.1. That means I go 2 to the left and up 5.1. So that's what I've done here. I went 1, 1, 2 to the left and up 1, 2, 3, 4, 5, 5.1. So I'm a little off there. -2, 1, 2. That's a 1, 2, 3, 4, 5.1. 5.1 is a little up there. So that would be -2, 5.1. Next I have -1, 3.4. So I go 1 to the left and then up 3.4. So let's see how well I did that. I go 1 to the left and up 1, 2, 3, and 3.4 is about there. So that's pretty good. If you use graph paper, it would be best. Your graph really will be accurate. Next I have 0, 2.3. I don't go any right or left. I just go up 1, 2, 2.3. You have to estimate where these are. So that's about there. Okay, next I go 1, 1.5. 1 to the right and up 1.5. So this is 1 to the right and then up 1.5 would be about there. Next I go 2 and then I go to the right and then up 1. So that's what I've done here. I go 1, 2 to the right and then up 1. So those are my points. So my points really don't look like that nice smooth curve that I have here. You see, it kind of looks like it might be a straight line. I know it's not because it's an exponential function. So what I had to do, class, I had to add on another point. So I added on -3. So when I substituted -3, I got 7.6. So that means I'm going to go 3 to the left, 1, 2, 3, and then up 7.6. All right, this is 1, 2, 3, 4, 5, 6, 7. So 0.6 would be about there. So sometimes you have to put these little tick marks in there to kind of get your graph accurate. As I stated, if you use graph paper, that would be better. So I suggest that you do use graph paper on these, but you know, as long as you're close, you'll still get full credit. So the tick marks, you have to get rid of those in the end. So then you draw a nice smooth curve. So it's going to be a nice smooth curve. Okay, you can see I'm a little off there, so I just I'm not using graph paper. So I just try to make it as accurate as I can, but a nice smooth curve. Okay, like that. See, it's not a straight line. If you draw a straight line for the exponential function, I won't be able to give you credit for your graph. It has to be a nice smooth curve. The exponential function cannot be a straight line. If you get a straight line, that means that you need to put in more points, just like I had to do here. I had to put in an additional point so that I would get a nice curve. Okay, for the exponential function, for homework, on page 430, you have to do problems 23 and 25. These two problems are problems on graphing the exponential function. And once again, for graphing the exponential function, you set up your table as indicated there. You're always going to start out with those same numbers. If you need to add a number, if you don't have a nice smooth curve, add a number on. It's best to use graph paper. You substitute these numbers into the exponential function, and you find the values for y. And then all you have to do, once you get the value for y, you just graph your points, as I've done here, and draw a nice smooth curve through your points. That's it. Have a great day. Bye now.